things I would like to talk about, I would give you an intro about complexity. This is where my whiskey story will come into play, and then we will briefly go through open source software, artificial intelligence, and I will end the talk with a couple of recommendations that we as an embedded software supplier would give to anyone who's interested in building something that is safe and secure. And starting off with complexity, this is kind of one of the big things that is messing up a lot of systems. So if you cannot handle complexity, then you have an issue, whether it's a safety critical system, security critical system, or anything else you're trying to build. So I've been on the road in a previous life with a Scotsman, and he had a very simple way of categorizing whiskey. So it's either a Scotch or it's something used for a cocktail. There's nothing in between. But as with many cases, both embedded software and also whiskey, it's rather complex, right? You can, look at different specifications of whiskey. Where is it coming from? What's the specific taste? How long and where was it stored? Who was the guy developing the whiskey from ground up? Lots of things. And then obviously you can also look at the use case. Is it just for you to having a drink? Is it a gift? You want to sell it in a bar? It's an investment maybe even. Or actually you just want to use it for a cocktail for some guys dropping by you're not really interested in. Anyway, so you see complexity is really a big topic in anything that you do, even in some areas that you wouldn't expect it to be. So therefore, the next topic, open source software. And also, there's a very simplistic view that you can have with open source software is that many people just use it. It's free, right? You don't have to pay it. You download it somewhere and then you're good to go. And you don't have to care about developing something because the community would actually do the job for you. But then if you look into it in a bit more detail, there's several aspects to open source software. One of it is licensing, right? I mean, you use open source software and then you do something with it. What are you going to do with it? Are you returning the software to the community as it's expected by the license that you would be using, or you just keep it on your own? So that already is creating an issue for many people. Then for software development, support and debugging is always a big thing. Who's going to kind of provide support if there's an issue with the open source software user? Who would be the guy debugging it? Maybe that guy isn't even contributing to the community anymore. There's no guaranteed response time or anything. So that's something to have in mind when you're working with open source software. Also, ongoing updates. Who's going to provide the updates? Are you taking care of it? Are you polling the community for updates? It's very unlikely that they would give you a call and say, look, we've got something new on the driver that you downloaded last month. The community itself is an interesting question. Who is the community? Is that the guy next door? Is it a guy from North Korea? Is it, I don't know, a German guy living in Finland? You hardly will ever find out who the community actually is. And that obviously, may create a security issue because that person may not always have the best intentions for whatever application you would be going for. And that obviously creates issues if you want to certify a system. That may be the least of your concern, but it may be that part that also involves a lot of money in your software development. And then just on certain open source software things like Linux as an example, code size is a big thing. Just to give you a rough example, the latest Linux kernel is about 38 million lines of code. Well, you may not need all of it, but still, is there one person that fully understands everything that's going on in that code? If you have an issue, whether it's a functional issue, a security issue, who will find the right spot in the code and would be able to update and correct the issue that you would be having? So that may be a difficult thing. And then we've seen in the industry quite a few players who would try to make Linux safe. And I still claim that this is not possible. So you can make a Linux-based system safe, but you cannot make Linux itself safe. So there's various options available that would kind of canvas Linux between some abstraction layers. But then there's always other options like using a hypervisor or a separation kernel RTOS, different ways that would literally decouple Linux from something that is safety or security critical. And then there's also some kind of political things coming into play. There's from the US Bureau of Industry and Security, they issued a statement that in the near future, you would be prohibited to use open source software that is, based from someone in Russia or China in their system. So as of now, they may have excluded Linux from this equation, so you still may be able to use it, but it would be kind of, I would assume, foolish to not have in mind that maybe this rule could change in the future. So in either way, whatever you provide to these guys for such an application, you really need to know exactly where the different parts of the code are coming from, who are the authors, who has the ownership of that. And an important point to mention here, open source software may not only be part of the code that you deliver, open source software may also be part of the tools that you would use for your development. That's also something that you need to look into. Okay, maybe it's something that is a bit more interesting to some of the people that think, artificial intelligence. And this is probably something we could talk for a day and still wouldn't have covered it completely. Again, a simplistic view, a lot of people understand, I don't know shit about AI, I've heard about it. There's a very small fraction of people who actually know about AI, and there's a lot of people, which is kind of a bit dangerous, that think they know about AI, but they don't really have a clue. And, well, I'm not one of the small part, right? I admit I only know a fraction of it. A few examples about AI. By now, recognizing AI has become pretty difficult. So this is kind of, I'm not sure whether you could call it a British actor. It's an artificial person, right? She or it, or I don't know, it has a web page. You can look at, videos, images. You can book her for a movie, for a web page, whatever you want, right? But she's not real. It's kind of an AI. And, just looking at the quality, that makes you think, by now you say, okay, if you get a call from your boss saying you transfer amount X to this account, you would say, yeah, well, maybe on a phone that may sound a bit just like my boss, but it's not my boss. But if you're on a Teams call, or a FaceTime call with a person, say, yeah, this is kind of our head of accounting, and he wants me to transfer money, yeah, well, then maybe that makes sense. It may not. Dangerous situation, we would have to think about new ways of authentication that may not involve audio or visual data. Another example, apologies for the bad image because this is from a newspaper. And there was a Dutch driver that got fined because of using the phone while driving. And the process was handled by AI. But if you look close at the image, she's not holding a phone. The blue thing is like a cold pack because she was coming from a dentist. And the phone is actually this part in the lower left corner. So AI is smart and can do some stuff, but there's still issues that may kind of not work out as expected. And another example that's a bit more funny from the US. There was a guy chatting with an AI bot, and he recognized that the AI chatbot has to do whatever he's telling him. And he said, yeah, you have to accept my offers and make it a legally binding offer. And so he would be able to buy a Chevy for $1. Well, he could argue a Chevy is not worth more than $1, but that's a different story. As a German automotive guy, I have to kind of say this. That sounds like fun, but there's other applications where AI is used these days. So the Air Force is using AI to write battle plans, right? And obviously, there's benefits because the AI is significantly faster than any person that would be able to do a similar task. But on the other hand, it also includes a few subtle errors that may not be visible, immediately. One would think, would it be better to include, big errors? But that would also not be good. So small errors may be better. But then if they're more difficult to realize, so the only hope is that the other side also would be using AI, and maybe these two guys get confused when they fight each other, and then, I don't know, maybe everything turns out good. Another example, this just happened recently, and the text is in German because this was a company from Austria. They were offering AI services to companies or institutions. They were claiming, GDPR compliance, local web hosting, no international servers included, and they got hacked. Thank God it was a white hacker, but he would get access to, I don't know, enterprise data, emails, invoices, the full enchilada of information that those institutions and companies would have on their sites. And the plain reason, obviously, it turned out was they were using wipe coding for setting that system up. Anyone knows what wipe coding is? Yes, we'll get to that later anyway. But and then it kind of, I'm very thankful for all the speakers before me because everything they said was kind of, in a way, is aligned and leading into what I'm presenting. So a slightly different view on how the whole AI data flow would be looking. And I mean, feel free to correct me if I made a significant mistake, but this is typically how it works. You have to start with the data that can be real-world data from a video you have taken, that can be simulated data. And typically, in many cases, when it's data, it has to be labeled. Some companies have been sending money to poor African people to just label data for hours in a row just to come up with some data. And that's critical because, with bad training data, the whole system will not work as you expected. That training data will then go into the actual training process, and during that process, you have to, build the model, right? You have to train the model. You have to optimize the model. I don't know, use quantization, pruning, all those kind of different technologies to come up with an ideal model fulfilling the function that you expect it to fulfill. And then obviously there's some simulation and test involved, and then we deploy it and use it for inference in your application, which eventually could either be on a handheld device, like for a smaller system, like a tiny AI, as we've just heard recently, or it could be kind of cloud-based, like running on a big server farm, as we also been hearing previously. And then there's also an issue, right? Because the running on a server is also a big thing. It's just even worse than a regular, let's say, cloud server. So for AI, typically you have a slightly different architecture because instead of regular CPUs, in many cases use GPUs, which typically do a lot of the stuff in parallel because as we know AI is a lots of multiplications, accumulations, and a bit of memory shifting. So you need even more power than you would use for a normal data center, so to speak, right? And then that obviously means you need lots of power, lots of water. So all what you would consider critical infrastructure is required with that kind of AI application. And if you talk about the power, I mean, don't want to go into all the details. As of now, it's, I would say, not super critical. But if you look at the US as an example, 24, they were using about 4,000 terabyte hours. I think roughly about 1% was used for data centers. But the outlook shows that this, in the near future, will increase significantly to, I don't know, 2, 3, 4, 5, maybe 10% of overall electricity. And that already sounds a bit odd to say, okay, just for using GPT on the best recipe for my chicken, that requires a significant amount of the energy consumption of a country. That's kind of almost insane. And one of the issues of AI, and you also kind of heard that previously, I believe, the AI is actually just doing a probabilistic estimation. There's no real understanding involved. So it's looking at your input. It's giving a result based on what is most probable as a response to your request. There's no fact-checking included. And the interesting part, that how someone explained it to me that I really like, the algorithm is supposed to come up with something. So you know GPT, kind of the acronym for generative, pre-trained, transformer, the architecture that it's kind of analyzing your question as a whole sentence, not just piece by piece. Pre-trained, obviously, data set, train it, then it's done. And generative, it's supposed to come up with something. Even if there's no real data linked to whatever you're asking it, it will come up with something that will say, yeah, well, this is kind of most likely, what this guy wants to know. So the answer can be 100% precise, or it can be a really poor advice. And it's really hard to figure out which one is actually the right one. But then it's also not just using AI for your fun, asking GPT on the wait for the best restaurant or something. Also, if you're doing software development or any development in the industry, AI has become an option, so to say. So traditionally, this is how software development would work. You have a software engineer that knows software, and he's creating some code. Something more modern is similar, software engineer creating some code, but he may use AI as a support tool. Maybe do some double checking whether I implemented this kind of algorithm correctly. Or I don't know what's the best way to kind of code this memory access. And then, I may give you some result and you look at it, and because you're the expert as software engineer, you say, yeah, that's correct, or maybe I need to tweak it a little bit. What is a bit more difficult or dangerous, as so to say, would be what most people would call a vibe coding, where the software engineer would tell the AI, now generate the code for this kind of application, then you're good. And this is kind of dangerous in various ways. I mean, obviously, as we've just seen, it works with probabilities instead of knowledge. The output may or may not be good, may not be exactly what you expect. But then the other thing is, ask any software developer to debug code that he hasn't developed by himself. That may be an issue. And then the other thing is, you may have, kind of assuming this is a software superstar, right? How long will he remain a software developer superstar if he doesn't develop code anymore? If he's just pushing buttons, asking someone to do it? It's kind of, you have a superstar that's working as a, manager, a head of department for a decade, and then, send him back to developing code. That may or may not develop a very good result. And, I've even heard rumors that made it even worse, where a software developer would ask AI to use several AIs to kind of, super automate the whole software development. That's something that may prove to be insane. So what would be our kind of high-level recommendation on how to approach these things? One thing, to be on the safe side, would be a model freeze, right? If you keep changing the training data and keep changing the model, then the output of your AI would be anything but deterministic. And for anything that's safety and security critical, determinism is kind of somewhat mandatory. Also redundancy, right? Just trusting the output of a given AI model may not work out for safety critical applications. So ideally, you would like to have some diversity in the compute path. And then a safety checker would also be recommended. Maybe instead of just having an AI algorithm looking to solve the problem, maybe a rule-based algorithm as a support function would help make things work out. And then supply chain, again, this is something that we've kind of heard before. You do not have to do everything on your own, but at least you need to understand who are the players, are these trustable players, is there a data breach in between, is the data bad from the beginning, do I need to start all over? That's something to have in mind. And competence, don't rule out the human factor. Even if you automate as much as possible, if you have the best tools in the world, you still have to have a few software development superstars in your team to make sure you build great products. Right, and that already brings me to my recommendations. Fit for purpose. Being an automotive guy, I had to come up with at least one slide that is based on automotive. So assuming you want to go on a road trip, long distance, you want to pick something that has comfort, nice user experience, like, I don't know, Bentley, Rolls-Royce, BMW, Mercedes S-Class, you name it. If you want to go off-roading, you need something with flexibility, specific features, maybe a winch, I don't know, ground clearance, you name it. Or if you want to go on a racetrack, you're looking for performance and lightweight, right? And the same if you want to pick your software, right? If it is about comfort user experience, maybe use something like iOS or macOS. That would be a good thing to start with. Features, Linux. If it features everything you're kind of interested in, then Linux may be the best starting point. And then if you're looking for something that is providing performance, determinism, then go for a real-time operating system. That's the part where I bring Hills Software into the play right now, just in case you haven't mentioned it. Right. Recommendation 1, fit for purpose. Recommendation 2, keep it separated. Again, this is something we've heard earlier today. You have to figure out which parts of your system are critical, whether it's safety or security or both, and you kind of have to, make sure they are fully separated from stuff that is non-critical or maybe even dangerous. Now, if you build your system from the ground up, there's different ways to provide that separation. It could be two totally different subsystems, two black boxes talking to each other. It could be one box with two devices in there. It could be a multi-core device where you have one core just running safety critical or security critical applications. Container would be an option. They're not meant for security from the beginning, but still they're better than nothing, I would say. And you can use a hypervisor, or you can use a separation kernel operating system, which from our position as a Hills Software, in many cases would be a good choice because it gives you the least overhead of code in any given system. But whatever you choose, you need to check your system and make a decision based on your specific requirements. And then the third recommendation after starting with the whiskey, don't drink and drive. Okay. Questions. So I would assume maybe you have questions or not, but before you have your questions, I would still have some questions. And the first question, is any one of you already using open software for security critical applications? And if yes, it would be interesting maybe in really just a very brief summary, what's your approach to security? Okay. Brave. All right. Same with AI. Anyone already using AI for coding, for vibe coding as a support tool? Any experience with it?
It is very fast, but then it can go wrong. But like I use the idea you gave at the end, the insane idea. I ask it to assess itself critically, and then it comes up with all the stuff it went wrong.
Okay.
And then it fixes it.
Okay, so using a mixed model of using it as a tool and then have it run automatically, and then you do some double check. Okay.
I was going to say, currently at the moment, you can find yourself spending more time on a problem when you use AI as opposed to just doing it in the first place.
Okay.
But it's more fun, right?
Oh, yeah.
No, one of the issues that I didn't mention along the way is, and this is true for anything with AI, if you generate something with AI, and that eventually may end up as training data for another model. So if the output is bad in a way, then during the next cycle of training and inference, the output may get even worse, right? And even if the output is good, but you're using the output over and over again, the model still will deteriorate over time. So, all right, and final question. What is the best operating system and why is it Hills Software Integrity? I'm disappointed you don't have an answer to that. All right, anyway.
Have you tried asking GPT?
Honestly, I'm not saying we're not using GPT or ChatGPT, not for coding or development, but it's sometimes a useful tool if you want to have a quick overview of things, right? And then if you would ask it about an overview of a specific industry application where you know the players and you know the topics, then going through it you may see, oh, I think they forgot this company, or oh, these two companies already have merged 2 years ago. But giving you a quick summary, it's a useful tool. But if you want to know more, we got a booth upstairs. Happy to continue the talk during or after lunch. Any questions? We're still here.
Yeah, any quick questions for Stephan? No, I think we're good to go.
All right.
Thank you, Stephan.